Hi everyone, today we're going to go over lesson 2-3, which is rate of change and slope. So again, as needed, make sure you go ahead and pause the video to take notes when you need to. Also go ahead and give it a pause when we're looking at the U-try so you have a chance to try it out for yourself. All right, so again, as I said, we're going over lesson 2-3, rate of change and slope. So our first example that we have here is in 2013, 31,388 students applied to Texas A&M. In 2011, ooh, there's a typo, 25,949 students applied. Find the rate of change in the number of students applying for the admissions from 2011 to 2013. So we're going to consider this as a constant rate of change. The first thing we're going to look at is to remind ourselves that the rate of change is the change in y over the change in x. So in this case, that is going to be the change in admission over the change in time. So we're going to take our first value, 31,388, and subtract our second value, 25,949. And our change in time is from 2013 minus 2011. When we do that, we're going to get 5,439 over 2, which becomes 2719.5. So the rate of change is 2,719.5. And this basically means that the number of students applying for admissions increased by 2,719.5 each year. So go ahead and pause the video and give this a try to find the rate of change in the data from the table. All right, so let's go ahead and take a look at this. We're going to pick 2 points, and we're going to go ahead and do the change in the rate of change. So I'm going to go ahead and use the first 2 points. So I'm going to do 16 minus 8 over 4 minus 2. And when we do that, we're going to get 8 over 2, which equals 4. So my rate of change is 4 feet per minute. All right, our next example for number 2 is going to be the average rate of change. So we're going to refer to the graph below, which shows the data on the fastest growing restaurant chain in the US during the time period of the graph. So we want to find the rate of change of the number of stores from 2001 to 2006. And so we can see we're going by the thousands and we're counting by the years. So the rate of change is the change in y over the change in x. So the change in number of stores over the change in time. So we're going to take from the graph, we can see it's about 33. So we're going to interpret that in 2006 there were 33,000 stores. And then in 2001, it's right above 5. So we're going to assume that it's 6 stores in 2001. And our change in time is from 2006 minus 2001. And when we go ahead and do that, we're going to get 5.4. So between 2000 and 2006, the number of stores in the US increased at an average rate of 5.4 times 1,000, or 5,400 stores per year. All right, here's you try number 2. Go ahead and pause the video and give this one a try on your own. All right, so refer to the graph, find the average rate of change of the percent of households with computers in the US from 2000 to 2004. And they were really nice here when you look at it in that they actually gave us the values that they want us to use. So in 2000, so if I wanted to write these as coordinate points, I'd write this as 2000, comma 61. And my other coordinate point would be 2004, comma 74. So these are my 2 coordinate points that I will be using. And so what we're going to head and use here is we're going to do 74 minus 61 all over 2004 minus 2000. And so you should notice that pretty much time is always in the denominator because that is going to be our independent variable. So that's not something that we really have control of ever. So that's going to be your x values. All right, so when we go ahead and do this, we're going to get 9 plus 4, 13 over 4. And so 13 over 4 is a little bit more than 3. And it's increasing, and we're counting by percents. So 3.25 per year. And the reason I knew it was percents was because it did say percents here, and we weren't counting per million. So that is very important to keep a note of. That can be a hint when you're looking at multiple choice problems. All right, so the concept that we have today is the slope of a line. The slope of a line is a ratio of the change in the y coordinates to the change in the x coordinates. So the slope m of a line passing through x1, y1, and x2, y2 is given by the formula m equals y2 minus y1 all over x2 minus x1. And we cannot have the same value for our two x values. All right, taking a look at example 3, we're going to go ahead and find the slope of a line that passes between -1, 4 and 1, -2. So we're going to use our slope formula of y2 minus y1 over x2 minus x1. So this is one coordinate point, this is the other coordinate point. They do have to match up. So we're going to do -2 minus 4 and 1 minus -1 to get -6 over 2, which is -3. So my slope between those two coordinate points would be -3. All right, go ahead and pause the video so you can go ahead and try this one on your own to find the slope of a line that passes through the points 9, -3, and 2, 7. All right, so here we go. I'm going to take my second y value, 7, and subtract the first y value of -3 and divide by 2 minus 9. When we do that, we're going to get positive 10 on top and -7 in the denominator. So my answer is going to be B. -10/7 is the slope of the line that passes through the two coordinate points 9, -3, and 2, 7. And for our last example, we have find the slope using a graph. So one of the things here is we are going to be looking at this. So looking at the graph, we can find two coordinate points. And we can see here is 1, 1 and -1, 0. So those are our two coordinate points. It actually doesn't matter which one you label y1, x1, y1, x2, y2. We could flip the order and we will still get the same answer. So here they went ahead and gave 1, 1 as x2, y2. So we're going to do 1 minus 0 over 1 minus -1, which gets us 1/2. So the slope of the line of this graph is 1/2. All right, go ahead and pause the video so you can give this one a try. Find the slope of a line. You are going to have to identify the coordinate points so that you know which ones to use. And they were really nice in that they gave you the nice clean points. All right, so here we're going to count 1, 2, 3, 4, 5, 6. So one coordinate point is -6. And we went up 2, so -6, 2. Our other coordinate point we have is 1, 2, 3, and it's on the x-axis, so 3, 0 is our coordinate point. So we're going to go ahead and do 2 minus 0 all over -6 minus 3. And that's going to get us 2 over -9. So A. Another thing you can do if you have really clear graphs is that you can do count on the graph itself the slope. As we can see that we're moving from left to right and we're going down, tells me I have a negative slope. And you can count that we have actually a change in direction of 9 and going down 2. That's another option you have if you have clear enough graphs to do that. And if they're really nice with the pacing on it. Otherwise, it's going to be easier to go ahead and use the coordinate points. That is the end of today's lesson. So I will see you next time when we go over 2-4.